Well, good afternoon. Today we are starting chapter 9, pointers. And one of the things that really boost your grade is we've done a lot of code listings. We have a lot in this chapter, and that really helps overall. And like I said, we have 23 out of 28 still in this class, and that's awesome. So, what's a pointer? A pointer. We've kind of worked with pointers already, but now we're going to delve into really taking an advantage of a pointer. And a pointer uses this ampersand that we've used already. We've used it with our what were they called? The
Reference variables?
Reference
reference
variable.
variables, right? And we used that whole idea of, hey, I want to change something and I'm going to use this ampersand so that when I pass it into my function, changes will take place. I'm just going to pass in the address so that when I get inside of there, I'm going to go to the address and actually make a change. And this ampersand is referred to as the address operator because it will allow what's being passed, this value that's being passed, to be the address of a variable. Okay. When we've seen it, it may have popped up once or twice in a code listing or something. We may have seen crazy numbers being hexadecimal. And oh, we don't get into a lot of studying with hexadecimal. You've seen it before. Some of you are going to get into my 230 if I teach it again. And all of a sudden I'm going to say, okay, 4-1 41FB plus 239A. Can you add those together? Can you work with hexadecimal? Yeah. Can you work with base 8? You know, a hexadecimal is called base 16 because we go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. My next number would be 10 all the way up to 1F, then 20. And just the same base 8 is big. But why is this big in computer science? Well, just like base 8, base 16 is a power of 2. And you'll do a lot of things power of 2 wise. And you already have started to. All right, we want to get ready on, and what do I have here? I have a reference to 9.1 for my code listings, and let's do this today. And here's ampersand X. It holds the value of the address. And slow down, you move too fast. Here we go. The address is 08F05. There's that F, which is the number 15. Yeah. Yeah. Hey.
Professor,
Oh,
if it's hexadecimal, what's the X in there?
um, I think that's to let you know that it's hexadecimal,
Okay.
but don't quote me on that. That's always what it's not like what the scientific notation where they throw that X in like it's just a placeholder. So it's yeah. I don't know is my answer. I have guesses of little things, but all right, where are we at here? We are at pointer variables. Array. We've done this. You already know it. We said we passed the array address. Numbers would be the name of an array. The address was being passed in. How it was received, we did something else. But as an argument, this is the address when we're dealing with an array. We just mentioned a moment ago, we used the actual ampersand the same way. This is the address of this primitive data type variable donut being passed in. And today we're going to look at a third pointer variable. Again, these are the first two we talked about. And we're going to create our own. And what we're saying is I want to store the address of what points to an integer. This is something that you're just going to live and die by. This is 162 data type. You're going to have null pointers all over the place. Null pointer is a location. It's location 0. So we could put the word 0 in here or null.
So it's
But
it's functionally the same as when we set a variable to 0 because we're going to fill it in with the data we want later.
yes.
Okay.
Yep. So we can create it one of two ways. The first way is the preferred way, and that is integer space this asterisk pointer. Now, this asterisk is going to get used two different ways. Right now, we're using it to create a pointer. We can put the asterisk beside the PTR, or we can put the asterisk after the INT. This is not very common to see. This reminds me that it's going to be a pointer. This is giving it an initial value, this null pointer. Different compilers. You may not be able to use null. You may have to use null, all caps, or you can get away with 0. Instead of null pointer, we can initialize it to 0. And as you keep going in computer science, you'll see more and more 0 has this great power all over the place. You typed in code listing 9.2. Where are you? At 9.2. Okay, I great example. X is 25. I create a pointer called PTR that's going to point to an int. It's going to point to a memory location that I'm worried about the 4 bytes after. Right now, it's pointing to nothing, null pointer. Now I'm going to say pointer, which holds addresses, is going to hold the address of where that is stored. It's secret where that is stored. Nine 9.3, again, null pointer might have to be null, but we're going to get into something that says, okay, so pointer knows the secret memory location of X. But what if I want to do a little bit more with that? And in this case, I want to work with the value there. Well, what this guy does, this new use for asterisk in front says, I want to go to the address and I'm going to dereference it, which means now I'm looking at the value that's there and I'm going to change that value to 100. So unlike I use this asterisk to declare a pointer variable, I'm now using it in a different sense to dereference pointer. So I can work with this says, go to this memory location, and work with the value. And work with the value. These two, asterisk pointer and X, are the same things. That is the same as that. That's kind of weird. Yeah. We're taking baby steps with working with pointers for what's coming down the road. So again, one of the real benefits, we can get right to where a variable is, and you're going to see that in a little bit. In fact, in a little bit, and you already know, we're going to talk about how array addresses and pointer addresses, we can work with these interchangeably when I want to deal with an array. But here it is. We use this thing in this asterisk. In this case, it's called the indirectional operator, and it's used to dereference the pointer, aka works with the value that's there. And we just saw that in code listing 9.3.
So it's really the difference between the value at the address and the address itself.
So this guy right here is going to be the address.
Right.
This is, so let me back up. I said that wrong. This guy right here is holding the address.
In hexadecimal.
Right.
Right.
This guy
That's the
is,
value that's at the address and allows you to change it.
yes,
Got it.
works
Awesome.
just like it's the X.
Yes. And the reason why we set it earlier equal to and or ampersand X was because at that point we were working with the address. We wanted the address, not the value.
Correct.
Got it.
Correct.
Just wanted to make sure I was digesting that properly. Thank
Yep.
you.
Yep. And of course it's easy for me now after all of these years, but I remember the first time teaching this. And again, it's not like this been 30 years because C isn't 30 years old. You know, there was C, which came first, and then C with all the add-ons. So this didn't just jump from me doing punch cards into what you do today. I've seen the evolution of the languages over time. Okay. So no, I do remember that it was not that simple. All right, any questions up to this point? And that gets us through those first two sections. All right,
Does
section 9.
pointer
Yep.
does pointer have to be PTR? That's the only one they
Nope.
referenced in the book, but
Nope.
okay.
Nope. I can tell you in CPS 260, we have front that we used. It's a pointer. We use back is a pointer. We use the word head commonly as a pointer. These are pointers to something to get the party started, blah, blah, blah. But all these different names. What's really common as well, temp pointer is a name that we use a lot in CPS 162. So all of these are declared. It could be int, temp pointer. Actually, we don't point to ints, we point to nodes and do all kinds of, but lots and lots and lots of names. There's also root. These are the 5 big ones we've used in the last month. They're all pointers to something. So the name can be whatever you want it to be. PTR just kind of says PTR. Okay. Relationship. A pointer holds an address. The array name holds an address. And when I come in here, if they're doing the same thing, they can be interchangeable. I have an array called numbers. It's an integer array. It's filled with values. I saw something I've never seen before. Last program, we're supposed to use random number generator. I think almost everybody did. There were a couple that didn't, that missed that somewhere. They just typed in an implicit list. But somebody, instead of having a loop for their numbers, they put rands, percents, whatever for each one of these. What did you have, rands? You know who I'm talking to. Rands. What numbers were we using? 1 to 50? They had that for all the elements. So they implicitly filled their array with random numbers by doing random 50. Rudy, that was you, right?
It was 51.
51, 0 to 50. Very clever. Very clever. Filled the array with random numbers, did it implicitly, didn't have to do a loop, anything. Must have found it somewhere. He didn't come up with this
I
one.
didn't. I was just really lazy and wanted to use copy and paste, and I thought, huh, this'll work.
There you go. It did. And I liked it. You got a shout out. Okay. So, numbers, as you remember, numbers is an address. So if I come down here and say, hey, I want to dereference what's at this address. That's going to be the same as numbers sub-zero. I want to dereference what's at this address. It's the same as I want to dereference what's at numbers plus one. One, which is actually going to be 1 times 4 bytes. As we've talked about with, uh-oh, my friend potential spam is calling. We're going to tell potential spam, no, thank you.
Sometimes I answer it and talk to them about conspiracy theories.
Yeah,
Once I asked them if they believed in the moon and they hung up. That's my tangent going.
maybe I'll use it. Yeah, but I think once you answer once, then their 5 friends with similar numbers all want to call. That gets to be annoying. Okay, as I was saying, numbers is an address. We dereference, hey, what's located in those 4 bytes? It's the same as numbers sub-zero. These two are equal to each other. Looks like
Professor,
we had,
if we reference it like that, if we do numbers plus two, is that adding the one to the hexadecimal of the address of numbers, and that's how they're stored?
so the way this is right now, this is going to add 4 bytes. It's going to take this address plus 4 bytes to the next address, then dereference it. If we did this, asterisk numbers plus 1, what would that give me?
It would give you numbers at 0 plus 1.
It would give me, yeah, the number 11.
Okay.
Yeah. What's that number sub-zero, which since we have it, plus 1, that would give me 11. This would give me 20. Okay.
Right, but is that how it's stored in the memory of the computer as an array? It's the hexadecimal at numbers plus whichever index of the array it is.
The data type. Yeah, the
Okay.
size. Yeah. Yep. So it moves across that way. Yep. Yeah, and 162, the memory addresses and memory, and boy, there's a lot of stuff we're gonna work on to keep clear. So let's see, couple of code listings. How are they tying in with this array stuff? And hopefully, as you look at these, you say, okay, yeah, okay, good, good, good. That's what we were just talking about here. This right here, this whole line is the same as this. Okay, this is moving, let's see, 4 bytes inch at a time. Oh, it keeps moving me over each time. And I read in and store. You notice the dereferencing going on with the indirectional operator.
So us keeping the parentheses there are the difference between it moving along in the array as opposed to just adding the value of count to the first thing
Yeah,
in the array.
yeah, well, it would probably give you an error because it's trying to read in a value, and what you would have is an expression that's trying to be calculated.
Right. Okay.
Yep.
Okay.
Yeah, 9-7. Okay. So here's what's going to happen for some of you. You're going to say, I think I got it, and then I'm going to confuse you. So let me know if I do. I'm not trying to. Coins, subnum coins. Good. Double pointer. Okay, it's just a name I made up. It's pointing to a location where doubles are stored. Might give myself a little bit, D pointer, so I remember their doubles. Don't know if I need that or not. Here I go. Here's the address of the array. It's being stored in this pointer. Remember, double pointer holds the hex. Coins holds the, I like that. Holds the hex. I just made this up, by the way. Holds the hex. I think Rudy kind of said this earlier. Holds the hex. This holds the hex.
That make
Now
it
we
like a
can,
grimoire
yeah,
because a grimoire would hold X's.
yeah, just like leprechauns or Santa's elves that drink too much and got fired. right?
And they just so happen to all be gingers.
Yes. It's what they drink.
There might be some correlation there.
I know. Think about that for a while. I think there is a moon. There's a alien substation on the dark side of the moon. Here I go. Double pointer. Remember that right there is replacing the word coins. These two are interchangeable. This is the address. That's where I'm going with it. Down here, I'm getting the value at coins plus 0 plus 1 plus. So now I'm back to using the array, but you notice I'm using the array without any subscripts because I can. I now know this is an address that I'm working with. Yeah, this one right here, this 9-3, it got yellow highlights, it got red underlines, it got a lot going on there. This is a good one. If you come out of this one okay, you're good.
Is like working with subscripts with arrays any different than working with, or not subscripts, sorry, pointers with arrays any different than working with pointers and vectors?
Pointers in vectors. Is that what you said?
Yeah, because the with vectors, right? Because they don't have a set size.
Right.
Does it
So
work the same, or is there?
remember what a vector is. It is a new data type that's created. That data type comes, it's got its like own class. It's got its own functions of how to work with it. It's got its own fields inside of that class if necessary. So that's an object of a class. So that's going to be a little bit different. What we're
Gotcha.
going to see, what some of you who are going to see in 162 is you're going to use these to create something called a linked list. And the linked list is what works like a vector. And I'm going to give you a 20-second preview of what I'm talking about. So you're going to create uh, a structure here. And a structure's coming up pretty soon, what a structure is. And a structure is going to hold a value, and it's going to also have a pointer. So this is a data type that we're going to make that has two things in it. We bind them together. This is going to be a node. And earlier I said I had a bunch of pointer names. One was head, and all head does holds the address of the first node. First node has a value and holds the address of a second node, and so on, all the way out until the last one points to null. Now, this is where it's like a vector, and this is why vectors, pointers to vectors are boom, because pointers are linked lists. This is called a linked list, and this is like the extravagance in all of 162. Because what do you do to these? Well, there's lots of stuff we can do, but some of the basics include, oh boy, if I add a number, where do I add? Do I just add it to the end? How do I get to the end? How do I traverse, you know, from head to this points to this one, to this points to this. So now I have a list that can grow forever like a vector. I have a list that I can shrink. Okay, I want to delete 23 off the list. I just point to 61 now. So this is going to be way, way, way more efficient than using vectors. And this is where you use a lot of pointers. You won't use them in vectors. Vectors, like I said, its own data type.
Yeah, that's what I was kind of thinking, is that because vectors work in their own unique specific kind of way, that this would not be something that would be efficient.
Right. Right. Yep. Yep. Good. Good question.
How would you
Nine
use
nine
a
was.
pointer with a two-dimensional array?
Can you use a pointer with a two-dimensional array? You mean to point to different values?
Well, in the same sense that you're cycling through and you're, adding count to the pointer and dereferencing it, how would you do that with a two-dimensional array?
Excuse me. Let me think on that a second. Never had the question about going through a two-dimensional array. I would just use a two-dimensional array.
Wouldn't it just be kind of like how when we use the two for loops going through one, like you just need to make note of the fact that you want it to run through the second one in that second for loop? Like obviously I don't know the syntax for that, but functionality you'd think it would be the same.
My my guess would be num plus one, like you're doing this, and you'd have, I don't know. I've never been asked that before.
Would it be a double parentheses? So like num plus one is your second uh bracket, and then in the other outer parentheses plus whatever for your first bracket, or vice versa.
Uh-huh. So I'm gonna say I don't know because this gets me to a certain location in memory. Okay, it goes to num, goes to first, and then I don't know if, say it's a 3 by 3, that I go to num and it takes me to the first block. And if that first one is 4 bytes, 4 bytes, 4 bytes, that's my first subscript. Then my second subscript would be the next 4 bytes. Okay, you're following what I'm saying? So this would be 4. So this would be 0, 1, 0, 2, 0, 3, 1, 0, 1, 1. What are you doing? 0, 0, 0, 1, 0, 2, and then 1, 2. So I would have to figure out a way to, if I have two subscripts, how do I multiply them to move out locations? Because it's going to still be linearly stored, the two-dimensional array. It would just be how I jump to it. And this might be why we need that specific third subscript or second subscript, so that we know that here's the first row, here's the second row, here's the third row. And then instead of plus one, I might have some kind of, yeah, plus one, plus two. This guy would be plus three, plus four, plus five. So this number times three plus that number. Subscript one times three plus subscript two. Would that work?
Yeah, that seems correct. Because that's three for,
One, two,
yeah,
three for
the three
moving
for the
it.
number of, yeah.
Yeah. I don't know.
Strange.
You guys keep distracting me all over the place here.
Use a vector, dang it.
Yeah, okay. All right. Sounds like a good idea. Implicitly initialized array. Boom. I have num pointer. Boom. Num pointer gets the same address as the array. What are we doing in here? I'm coming through and I am printing out everything that's in the array. This is great. But when I'm done, where is num pointer? Okay, so num pointer is here. I do the plus plus, it puts it at the beginning of 10. I do the plus plus, the beginning of 15. Fast forward. I'm at 35. I do the plus plus, it puts me at 40. And I just printed out 40. It does the plus plus and puts me here on the other side of 40. Now, this guy says go backwards. I do minus minus first, so it moves me 4 bytes to the left to the beginning of the 40 and prints it out. Moves it to the left and prints, to the left and prints. So that moving of the 4 bytes left and right Yeah, but I needed to do it by hand so I could make sure I knew where it ended, that I had to start out by moving me to the left. Questions? Good. 599.4. 9.4. Cheese and crackers, Alice. Now, you really did it, didn't you? X equals 50. No, Y equals 60. Z equals 70. And X gets the value of 50, Y gets the value of 60, and Z has the value of 70. That's from the previous page. All right. Pointer equals ampersand X to start. I'm coming back over here. I have pointer gets the address of X. So now when I come over here, what is the new value of X? What is the new value of Y? What is the new value of Z?
Taking a guess here, would it be 500, 300, and 140?
Yeah, I'm going to take what's a pointer right now, multiply it by 10. That was X. Then it goes to Y. So yeah, there's those values. Who the heck writes in pen in my book?
Some guy. You should probably find him.
I know.
Yeah, they have medication that'll help you with that.
I
You
think
can't make me.
I saw him today in the mirror. He was looking pretty rough. Okay, there we go. Let's see what you know. Let's see what you know. 9.8. What's valid? What's not valid? Letter A. What do you got?
I think it looks right.
Yeah, A is valid.
Okay, so I have a variable ivar, and I'm saying, remember, this is just declaring. I'm not dereferencing yet. I'm declaring a pointer, and it's getting the hex. It's getting the hex, getting the address. B, valid or not?
It was messing with me at first, but they are both ints, even if they're doing different things.
That's these two lines just on one line.
Right. Yes.
Yep. Letter C.
Mismatched data type.
Mismatched data type. I'm trying to, yeah. I'm trying to get the hex address of a float, and I'm saying, hey, I want to point to an integer, so that's wrong. Yeah. What else we got? D.
B's good.
We like it. Okay, I create an array, size 50. The address is here, and I'm storing the address in a variable that I'm creating to hold the address. And letter E.
Is Ian valid?
So I'm asking you if it's valid or not, and you're turning around
Would
asking me if
Yeah,
it's
I'm looking
okay.
at it. It's just
Wouldn't you need to declare
You
the int
declare it
ivar
first.
first?
yeah, because the
This
order
Out of
needs to
order.
be
matters.
Yep, that would need to be done first. Okay, good, good. Let's keep rolling here in chapter 9.
I bet the guy that's writing in pen in your book wrote that one.
Yes, he's all mixed up. My all shook up. Comparing pointers. Nice to know. I can use all of my, what were these called? These were called the
Huh.
operators.
Logical operators. Comparative
No.
operators.
Comparative. Relational, yes.
That's
Relational.
it. That's
Relational
it.
operators, yeah. These are all my relational
Synonyms.
operators. Logic deals with logic and not or
Yeah.
kind of deal. So
True,
yes, we can
false.
use them. Comparing addresses, they're going to be linear. What about, I want to start looking at, can I pass them? The answer is yes. You're just passing addresses like before. So earlier we did void bubble sort. Hey, I'm in my prototype. I'm going to pass an integer array and just some int. And then in my actual calling of it, I'm going to say bubble sort, and I passed the address to an integer array. It just happened to be the array name. When I land down in my bubble sort, I am coming up with parameter list. This guy says, hey, I'm creating a local variable. I'm creating a local variable. It's an array of integers, and this is where it's at. Whatever the hex of values comes down and lands in array. Man, we're starting to get into deep with stuff we've always just did for granted. Starting to get it to make a little more sense. Look at the next one for a second. I am saying that I'm going to, interesting. Hmm, that, yeah. Values, that's the same. Int, I'm going to create an address. I'm going to call it array.
Is the asterisk there just saying you're passing the address into bubble sort?
Yep. Full sort. We're done with that. I hope you all save that program and someday you go, hey, I need a sort. And I go and cut and paste it and say, oh crap, I need it for Java, not C. Excuse me. Okay. Here's what I want you to do. I am jumping the page. Ba, 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 ba. Where am I at?
You're home, I hope.
I am. I am. I want you to, yeah, we're not going to do that. If we had a whole nother day, we would do. I'm going to page 553. Cha-ching. And I want you to write this program. Cha-ching. Number two. Number two says, write a program that dynamically allocates an array large enough to hold a user-defined test scores. Once all the scores are entered, the array should be passed to a function that sorts them in ascending order. Another function can then calculate the average out of sorted list. And oh boy, yeah, sure. I'm going to write a program, and I want you to write it with arrays. All right. When you're done writing this with arrays, I want you to go back and change as much as you possibly can to pointers. So you see what I want you to practice. Something we've already done, so I get a nice program and I have a nice feel for it, and we're going to have functions, etc. And then when you're done, go, well, wait a minute. We can replace this array with linked list. So I need to come up with a main to make sure we all have the same main. Write a program that is going to fill an array of numbers. Agree? Fill array of numbers. Send them to a sort. Then go find average. Then display everything. I need fill an array. I need sort. I need calc average. I need display. Type of thing going on here. I need fill an array, and we're going to fill it with random numbers. You can actually cut and paste this from your last program. Array size 10, numbers between 1 and 20. Okay? So I need to fill an array. This is going to be whatever I put in here for array. The types. Now I need to pass the array into sort so it comes back sorted. Then I need to pass it in so I can calculate average. And then I want
The
to
average of all the numbers in the array.
yeah.
Okay.
And then I want to pass that and average and my array into display. So I need to fill an array. Then I'm going to pass it in and get it all sorted. Then I'm going to pass it in and get the average. And then I'm going to do the whole display thing. So you're going to write this main with arrays right away. Some of you are getting to the point where we can cut and paste this. We can cut and paste that. The average is going to be simple. Da 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 da. Good. I got it done with arrays. Perfect. Now, where can you make as many possible changes into pointers like we just talked about? Sound easy?
And anywhere there's an array.
Can we?
I believe so.
I hope so.
I'm gonna find out.
We're going to find out. All right. I'm going to stop the